Okay, have a go at this yourself first, and then watch this video afterwards to see how I would do it, okay? So, what is the name of a position of a gene on a chromosome? That would be a locus. What is meant by genetic diversity? That would be the number of different alleles. Really important. Alleles of genes in the gene pool. Now, if we just look at what the mark scheme says for this one, what you've got to remember about AQA is that these are all the worst possible answer that you can get away with and get a mark for. Okay, the answer that we want in this case is there. Okay, as long as the candidate was talking about there being differences in the DNA or in the base sequences, that would have got the mark, but it doesn't mean that's the best quality answer. Okay. Geneticists investigated different diversity amongst 4 breeds of dog. She compared DNA-based sequences of the same genes from a large number of dogs from each breed. Okay, a large number. The geneticists calculated the mean genetic diversity for each breed of dog. The mean value of this was between 0 and 1. A value of 1 is maximum diversity, 0 is no diversity. So she's looking at the genes of these dogs, and if they're the same between the 2 dogs, 3 dogs, whatever, that's going to be a score of 0. And the 2 that were the most different get a score of 1. Okay, so she sort of quantified the genetic diversity. The results are shown in the table. So we've got 4 breeds of dog. We talk about breeds rather than species because all dogs are the same species. We can look at this later, okay? When you have selectively bred organisms, farm animals or pets or whatever, then we talk about breeds, okay? This is the diversity here. Scores between 0 and 1. And this is the standard deviation. Okay, so standard deviation is something you might as well get your head around now. Let's go. There's a couple of different ways of calculating it, okay? The sort of simplest way of doing it is this formula here. I'll talk about what it means. Some of you will be quite happy with this anyway. Okay, it is a way of measuring the spread of data. Remember, they looked at a whole bunch of different dogs, right? So a large number of Airedale Terriers, a large number of Bull Terriers, a large number of Jack Russell Terriers, a large number of Miniature Terriers. And then for each breed of dog, they've calculated a standard deviation. So there would have been a bunch of different dogs, right? Let's say there's like 20 different Airedale Terriers that she looked at. So she would have got a genetic diversity for each of the Airedale Terriers. One of those Airedale Terriers would have had the lowest genetic diversity. So if this is the genetic diversity, right? One of them would have had the lowest, one of them would have had the highest, and they would all have been spread out along here somewhere. Okay. Now, if they're spread out like that, that's pretty even, right? That wouldn't be a normal distribution, right? If this was a normal distribution, we'd expect there to be more of our dogs sort of in the middle here with this sort of genetic diversity and fewer at the extremes. okay? The standard deviation is a way of measuring how far, on average, each data point is from the mean, all right? Or it's a way of looking at the spread in the data, but it's better than range. The range would just be the highest and the lowest. Okay, so if we had, let's say, a data set like this, where it's 0 and there's 1, maybe this is the bull terrier, right? We've got one there and one up there, I don't know, and then all the rest of them here, blah, 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 right? Then the range would still be from that one to that one. Okay, you might be thinking, oh, that one's an outlier, it's an anomaly. Oh, look, okay, no, it's not. So even now, the range isn't particularly helpful because most of the data points are clustered up here. So our mean's probably around here somewhere. No, maybe not there, up here somewhere. And then your range is still from your lowest to your highest. You know, plotted on a graph, you'd have your mean and then your highest and your lowest, right? Your standard deviation is a way of measuring, on average, how far each of the data points is from the mean. Oh, I don't know what happened there. Just fill that back in. So what we've got here in standard deviation is x minus x with a hat on. That is the mean. And x is each data point itself. So x minus the mean is basically, let's just do this, I'm playing around with this now. X minus the mean is a measure of how far everything is from the mean, okay? We want to find out on average how far everything is away from the mean, so we add up all of the differences from the mean, that's what this is, the sum of, and then we divide it by the number of data points that there are, you know? So if there were like 20 data points, we add up 20 times how far each data point is from the mean, and we divide it by the total number of data points. Now this is the total number of data points. This is -1. This is a degrees of freedom deal, right? We're saying that there is 1 degree of freedom. Now, don't worry if you don't know what that means. We'll look at that another time. But you have to do it, basically. And then, because if this is the mean around here, because these values are bigger than the mean, if these values are smaller than the mean, you can't just add them all up because some of them are negative and some of them are positive. So first of all, you have to square them. Then you add them all up, divide by how many there were, -1, because of a degrees of freedom thing. And then because you squared it, you've got to square root it. Okay? And then that gives you something called the standard deviation. You can still put standard deviation on the graph. You get the mean, but instead of getting the highest value and the lowest value, you get, on average, how far away are each of the values from the mean. And it gives you, you know, a bit of data that's a bit more. These bars then become a line that represents how far each value is from the mean. Once you've got your standard deviation, say you do this sum and it turns out, I think I'm doing something when I touch it, aren't I? When you calculate S, you only need to do it once, and then you've got the standard deviation from the mean, and then what you do is you say, okay, I'll plot my mean, and I'll plot one standard deviation higher than the mean, and one standard deviation lower than the mean. Okay, so if it is like genetic diversity, ooh, this is genetic diversity 0, 1, and then dogs here, right? And so there's 0, there's 0.5, there's 1, there's 0.75, There's 0.25, right? Let's say we get a standard deviation of 0.25. So we would plot the mean there, and then we see we've got a plus 0.25 and minus 0.25 standard deviation, see? If your spread of data doesn't look like this, but is, a normal distribution, then one standard deviation from the mean would incorporate 68% of the data. That's one standard deviation above and one standard deviation below the mean. Okay. And two standard deviations, that would include 95% of the data points. All right, if it's a normal distribution. If it's not a normal distribution, that would be true. But if it's a normal distribution, one standard deviation will include 68% of the data points, and two standard deviations will be 95% of the data points. Okay. So what do these data show about the differences in genetic diversity between these breeds of dog? Well, we've got what do they show is basically, what's the graph telling us? What's the table telling us? Okay, can you interpret this as data and say what it's saying? So the highest number here is Jack Russell Terrier. Jack Russell Terrier therefore has maximum genetic diversity is 1, has the most genetic diversity. So the Jack Russell Terrier shows the most genetic diversity. The least genetic diversity would be shown by the Bull Terrier, because that's the lowest value there. Let's have a look at the standard deviation. So Airedale and Miniature Terrier, they look like the two that are the most similar. Airedale has a standard deviation of plus 0.03. So that means that we've got 0.54 if we add one standard deviation, and 0.48. Ooh, yeah, that's right. If we take away one standard deviation. Yeah. And straight away, you can see with the standard deviation of plus 0.02, this becomes 0.49 if we add a standard deviation. All right. And, 0.45 if we take one away. But these now overlap. Okay. So graphed, what we find is that these two data sets, even though the mean is outside of the data set standard deviation, the standard deviations overlap. Okay. When the standard deviations overlap, that means that the difference between the two means, is not significant. Okay. So you would say that for the Airedale Terrier and the Miniature Terrier, the standard deviations overlap, and so there is no significant difference between the mean genetic diversity of the Airedale and the Miniature Terrier. Okay. Miniature Terriers were first bred from Bull Terriers in the 19th century. Suggests one explanation for the observed difference in genetic diversity between Miniature Terriers and Bull Terriers. So the Bull Terriers show less genetic diversity than the Miniature Terriers. Right, so how is it possible? We had Bull Terriers, .38. Some of those have been used to get the Miniature Terriers. They're at 0.47. They've got more genetic diversity than the Bull Terriers. Now, there's a number of reasons that this could have happened. Okay. Somehow that population has got more diversity, therefore it's got more alleles in it than that population. Now, the same length of time has passed for both of them since they started breeding some of them into miniature terriers. So you can't go saying, oh, there's more mutation in the miniature terriers. The mutation rate is kind of a fixed thing. It happens at a particular rate over time. So it's not that. Okay, there are other ways to get the genetic diversity down or up, and that would be to do with the losses. Okay, if you've got more losses of members of the population, then you're going to get less alleles passing through, and then you're going to get more less genetic diversity. So it's possible that the bull terrier population became very small. Okay, and therefore there's less of them. Whereas the miniature terriers, there are more of them, and therefore the range of allele types has grown, and with it the standard deviation. Okay, so that you could say that the bull terriers are from a small population. It could be that there were a lot of them, and then the population size fell. Now we have a name for that, and if you look, it's on the mark scheme down here. It's called a bottleneck. Okay, so you've got your population. So maybe each of these different dogs is each of these different dots is a dog. Okay, and then if we have time passing in this direction here, all right, they then give rise to the next generation. There they are. Happy dog days pass. They give rise to the next generation. And then something happens which means that we lose a whole bunch of them. Okay, now, maybe they go out of fashion a little bit because these are dogs after all, right? So there's less in the next generation. There's less in the next generation again. Less in the next generation again. These guys just aren't selling, right? Nobody wants them. They don't go completely extinct. There's still a few dog owners out there, but during this time there isn't much variation in the population. There's only a few individuals at any one time in the population, and then maybe after that they start to become more popular, and with each generation we find that more of these guys are getting to breed, or keeping more of the puppies. Okay, the puppies aren't being destroyed, which is what would be happening if these dogs weren't in fashion, and population starts to recover again. Now we call this a bottleneck because it looks a bit like a bottleneck. All right, so they've passed through passed through a bottleneck. All right, that's what it's meaning when it says pass through a genetic bottleneck. Okay, more inbreeding would mean that all the dogs you had here were just breeding with each other. Well, that's what we were talking about anyway. Like, what are they getting at? Well, inbreeding. This population was only breeding with itself anyway. Well, that only makes sense when you look at the next option. For the miniature terrier, there's been more outbreeding, you see. So outbreeding is when you're introducing alleles from another breed. Okay, so you've got your bull terriers population in here. There's your bulls, and you've got your miniature terriers over here. There's your miniature terriers, but the control of the bull terrier population has been a bit stricter than the miniature terrier population, and other dogs have been allowed to mix with the miniature terrier population, breed with them. So you've got this gene flow between the miniatures and just like other dogs. And then that introduces other alleles into the miniature terrier population. Okay, so that's what's going on there. Okay.